All right, we are going to be focusing today on end behavior, but before we get to that, I want to give you some time to just do a quick little review of what it means to evaluate, find a value of the function for the given value of x. So f of x equals 7x minus 6 when x is equal to negative 2. Means I'm looking for f of negative 2. Replace every x that I see with a negative 2, and then carefully follow my order of operations. F of negative 2 will be equal to negative 14 minus 6, which is negative 20. So I could write that as a coordinate point. In goes negative 2, out comes negative 20. So go ahead and pause your video, try the next ones, use your calculator if you need to, and make sure you're following order of operations. Pause your video. Pause it now and try. Pause. All right, I'll give you a chance to go through and check your answers. For number 2, I got 39. For number 3, I got 10. For number 4, I got 40. For number 5, I got negative 45.8. And for number 6, I got 33.96. Please note that for number 5 and number 6, you definitely should have taken out your calculator, and you are definitely going to want your calculator if you haven't already taken it out. All right, next one, match each polynomial function with its graph, explain your reasoning. So what I'd like for us to do is think about our degree with even and odd, and think about how these things are going to play together. So if I think about these ones down here, okay, x to the third and x to the fourth, those are what we call parent functions. Those are nice and perfect. They haven't been shifted, stretched, added other things to it, subtracted other things to it, moved around, etc. So positive x to the third should have end behavior that looks like this, and it's our perfect going through 0, 0. So that's going to be letter E. X to the fourth is a positive even, so we're going to have end behavior like this. So it looks like my options are C or F, but I know this one is a perfect 0, 0, and that's the only 0 that it has. So that's going to end up being F. Looking up here then, I have a positive odd. So I should look like this. Well, positive odd, the only one that's left now is going to be A. Looking at this one, I have a negative odd. So that's going to be up, down. That's going to leave me with D. Thinking about this one, I have a negative even, so upside down, because we've got down, down, that's going to be B, and then process of elimination, positive, even, we should end up with C being our last one. Okay, so all of that has to do with end behavior, but then more specifically, I narrowed things down by finding other zeros. So this right here, x to the third minus x, if I take out an x, I'm left with that. And so I should have a 0 when x equals 0, when x equals, so when x squared minus 1 equals 0, which means x equals plus or minus 1. And I've got a 0 there and a 0 there. So that all checks out for me. This next one, if I factor something out of here, if I take out a negative x, I'd be left with positive x squared minus 1. So I should have the same zeros, negative 1, 0, and 1, except my graph is going to go the other direction. It's going to fall to the right. Thinking about number 3, okay? Number 3, if I set that equal to 0, I'm going to end up with just zeros at 1 and negative 1, which is what I have going on right here. So if I set this whole thing equal to 0, I would subtract 1 and take a 4th root. And then finally this last one, if I factor out an x squared, I'd be left with x squared minus 1. So again, I get a 0 at 0, and I get zeros at plus and minus 1 when I solve that. So negative 1, 0, and 1. Mostly though, you can go by end behavior, okay, for these graph matchings. Let's talk about end behavior. So when we think about the number line, if this is our x-axis, you don't have this in your notes, and that's okay. I just want you to listen. You can jot stuff down if you would like to. But if I think about this being my x-axis, and I have 0, and I start counting this way, eventually, way out here, my x's get infinitely big. If I start counting to the left, -1, -2, -3, eventually out here, my x's get infinitely big, but in the negative direction. So this would be x going to infinity. This would be x going to negative infinity. Well, the thing is, a y-axis, if I start with 0 and I continue on positively, this would be y going to infinity. This direction then would be y going to negative infinity. And the beauty of our coordinate system is that, let's see if I can get this all grouped together, maybe. There we go. If I group that all together, the beauty of our y-axis is that it's just a number line that has been turned and matched up. So when I think about my coordinate plane, try to get all of this together. Group this. When I think about my coordinate plane, it's really just two number lines that have been grouped together. There we go. And this one, y is going to infinity. There was my y-axis. Did I lose my y going? Oh, there we go. Y going to negative infinity. So when I think about those tails, for instance, a disco man that looks like this, I could say as x goes to infinity, my y's are going up to infinity. Or as x goes to negative infinity, my y's are going to negative infinity. And that's what we're going to work on this next slide. So we still want to think about our end behavior just like we did before. So degree being odd and positive. Go ahead and fill in those words. Odd and positive. You guys learned before that your end behavior was down, up. Still true. But the way we're going to start talking about it is as x goes positively, what does y or f of x do? Well, as x goes positively, y also goes positively. Next one then, as x goes in the negative direction, what is my y doing? Y, or f of x, is going to negative infinity as well. Okay, next one then, I've got an odd degree polynomial, this time with a negative leading coefficient. So my arrows should look like this. But what that means is this time, as x goes to positive infinity, right? As x goes to positive infinity, now my y's are going to negative infinity. As x goes to negative infinity, so moving to the left, this time my y's are going to positive infinity. Okay, so we're thinking about what's happening at the ends of our graph. As x gets really big, what does y do? Does it get really big positively or really big negatively? And vice versa. Okay, next one then. Let me erase that. Next one. We have an even degree with a positive coefficient, so up and up, which means as x goes positive, y goes positive. As x goes negative infinity, y goes positive infinity. Everything's going up. As x gets big, y gets big. As x gets big negatively, y gets big positively. Okay? And then the last combination would be down and down. So as x gets big, right, we talk about x is independent. As x grows really big, y goes big in the negative direction, because of those down arrows. And as x gets big in the negative direction, y also gets big in the negative direction. Okay, so we're just going to think about these a little bit differently. As x is doing something, what is y doing? Go ahead and pause your screen and make sure you have everything filled in here for all of your blanks that you have. All right, describe the end behavior. Well, upon initial inspection, this is a positive odd degree polynomial. So my arrows from before would have looked like this. So I'm going to say as x goes to infinity. So as I read my right arrow, y also goes up to infinity. As x goes to negative infinity, my left arrow, my y is going down to negative infinity. Next one, f of x is positive and even. So my arrows would look like this. So as x goes to the right, positive infinity, my y is also going up to infinity. Thinking about my x going to negative infinity, my y is going up to infinity. The next two, I'm going to get you started on arrows just in general, and then you're going to do some work to write the x's and y's and see if you can do it. So I have a negative even, so down and down. As x goes to infinity should be that arrow. As x goes to negative infinity should be that arrow. So see if you can tell what y is doing. For the next one, I have a negative odd. I want you to see this is the right arrow. This is the left arrow. See if you can write what both x and y are doing. Go ahead and pause your video and try these now. All right, take a look at those. Notice that I start these problems the same way every time. X to infinity, x to negative infinity. X to infinity, x to negative infinity. X to infinity, x to negative infinity, etc. You see what I'm saying here. It's the y's that change because the y's depend on what the x is doing. So as x gets big positively, what does y do? As x gets big negatively, what does y do? That's our trend. Okay, these last ones, I want you to graph them in your calculator just to verify the end behavior. So you should take some time, type these into your y1. Okay, you'll type in this function and then press zoom 6 to see what your ends are doing. Go ahead and pause your video and try to fill these in for your end behavior. Right, so you're going to start each one with as x goes to infinity, what's y doing? And as x goes to negative infinity, what is y doing? See if you can answer those from looking at your graph. Go ahead and pause your video, finish out these 3 problems just by looking at your calculator. Okay, these ones you should just be practicing in your calculator. You could have looked at them, or you could have done the degree analysis to figure out which one's which. But again, notice I always talk about x getting big first in the positive direction. Then I think about x getting big in the negative direction. Doesn't matter, but you want to make sure you're talking about both ends of that x-axis. So this is x going to infinity, and this is x going to negative infinity. So everything I've color-coded, red goes that way, green goes that way, if you're trying to keep up with the colors. All right, that's it for your end behavior. So we're moving from just arrows to talking more mathematically using those infinity symbols. Thanks for watching.